Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we'll study about a decoder. Now let us start understanding what exactly we mean by decoder. Decoder is also one of the combinational logic circuit and it has a multi-input and multi-output. So decoder is one of the combinational logic circuit with multi-input and multi-output. For n number of input, we have possible outputs are 2 raised to n. For example, if we have 2 input, maximum output possible that will be 2 raised to power 2 and that is 4. Same way, if inputs are 3, then maximum possible outputs are 2 raised to power 3 and outputs are 8. We have coded data at the input side and coded data is transferred to the output side. In decoder, for each possible input combination, only one output line is activated. Meaning is, for each combination of the input, the data is transferred to the selected particular line at the output side. Now let us see the block diagram, then it will be very clear. We have block diagram of decoder. We have n number of inputs and we have m number of outputs, and m, that is 2 raised to power n. So we have relationship between input data lines and output data lines. So we have m number of outputs. This is basic block diagram of the decoder, and for each input combination we have selected one output line is activated. Now let us study one of the decoder with input 2. If inputs are 2, then output maximum possible, that is 2 raised to power 2 and that is 4. So it is known as 2 raised to 4 or 2 to 4 decoder. So first we understand the block diagram. Now we have block diagram of 2 to 4 decoder. We have 2 input, that is A as well as B, both are input. And as I said, if we have 2 inputs, then maximum 4 outputs are possible, and that is known as output data lines. So D0, D1, D2 and D3. So coded data at the input side, that is transferred based on the input combination to any one selected output line, that may be D0, D1, D2 or D3. We would like to design a combinational logic circuit for 2 to 4 decoder. So first we have design statement and accordingly we have prepared block diagram. Now based on this block diagram, we will prepare truth table, and we have only 2 inputs. So truth table is simple, and from the truth table we'll be designing or we will be implementing the logic circuit for the 2 to 4 decoder. Now let us see the truth table for 2 to 4 decoder. We have 2 inputs. Inputs are A and B. Possible input combination, that is 0, 0, 0, 1, 1, 0 and 1, 1. And we have 4 number of outputs. As we discussed earlier that if we have 2 input, then output will be 2 raised to power 2 and that is 4. So we have 4 output data lines, D0, D1, D2 and D3. As per the definition of the decoder, for each input combination, only one output line will be activated. Meaning is, for each input combination, only one output will go high and all remaining output will remain at the low level. For example, let us have a first combination, that is 0 0. So only one output line, that is D0, is activated and it will go high. All remaining output lines will remain at 0 level. For another condition 0 1, the second line D1, that will go high. All other remaining data lines will remain at 0 level. For next condition, that is 1 0, data line D2 will be activated and it will go high. All remaining data lines will remain at 0 level. And for the last condition, that is 1 1, so output data line D3 will go high. Output line D3 is activated and data, whatever data is available at the input side, that is transferred to the selected activated output line. Now based on this truth table, we have combinations are possible. So it is a logic combination. To maintain D0 high, we require this combination, and that is 0 0, meaning is A bar, B bar. Same way, for each output line to be activated, we have possible input combination 0 1, A bar B, 1 0, A B bar, and 1 1, that is A B. So these all are product terms. So we require AND gates to implement the logic circuit for 2 to 4 decoder. Now let us implement the logic circuit based on the truth table. So truth table is reproduced for our ready reference. We have input A, we have input B. We require A bar as well as B bar. So we use the NOT gate to get A bar as well as B bar. Now we have 4 product terms. So we require 4 AND gates. Each product term has 2 literals. So all the AND gates are with 2 inputs. So for the first data line D0, the logic is A bar, B bar. So we give input as A bar, B bar, and in this particular combination we will have output line, and that is D0. For second output line, we have combination, that is 0 1, and it is A bar B. So A bar B input combination and output possible, that is D1. For the third output line, that is D2, and we have input combination, that is 1 0 and 1 0, that is A dot B bar. So A dot B bar, and we have third data output line, and that is D2. And for the last D3 output line, we have input combination is 1 1, meaning is A dot B. So we give A dot B and we have output, that is D3. So now from the logic circuit also we can understand that for each input combination only one AND gate will be activated, only one output will be available at a time. It can be either D0, D1, D2 and D3. The understanding of the decoder is like that. For each input combination or the data available at the input side, that will be transferred to selected output line. Only one line is activated at a time, and that is the definition of the decoder. Thank you for watching my video. Keep watching. Thank you very much.